So in this video lecture, we are going to analyze a fixed beam with a point load with a differential span location. Okay, we are going to use theorem of three moment for this problem. Fixed beam is normally an indeterminate beam. So a simple theorem of three moment equation for a continuous supports system in the span of L1, L2, and if you consider moment at A, moment at B, and the moment at C, three supports, and if it is loaded with some loading, and if you consider the area of the loading diagram, A1, A2, and the centroid from A is x1 and centroid from B is x2. So these are all the parameters needed to write a theorem of three moment equation. So the first equation is MA into L1 plus 2MB into L1 plus L2 plus MC into L2 equal to the right side terms minus 6A1 x1 by L1 minus 6A2 x2 by L2. So this is the common format, simplified format of the theorem of three moment. So in this fixed beam, we have only one span. There is no the second span. We have to make over that by considering an imaginary span first on the right side and create a point B dash, A, B and B dash of the zero span. Consider L2 as 0 as well as MB dash equal to 0 because it is an imaginary point. By using these three terminologies, we can write the theorem of three moment equation for this system of loading. Here we consider point load, the different space. So definitely support A is a fixed support, so moment at A will exist and the span is L for the L1 span. So L plus 2MB is also exist because it is a fixed support, and L1 is L but L2 is equal to 0. So make it 0 plus that is the moment MB dash and the span is 0. Also MB dash is also an imaginary point, so make it 0 minus 6 into A1 will be there because it is a real span, real loading. What is A1? The area of loading diagram. So it is unsymmetrical triangle. So what is the bending moment value for a point load with the spans A and B? So PAB by L is the moment value. So A1 equal to PAB by L, and centroid. It is an unsymmetrical triangle. So the centroid will be at a distance of L plus A by 3. Here L plus B by 3. Kindly note it down. L plus A by 3 and L plus B by 3. So here we can take the area of this bending moment diagram half into the span is L and the height is PAB by L. PAB by L 6A1 and the x1 is from A on the left side, which is L plus A by 3. L plus A by 3 divided by this L1 is the span L. Is the span L. Minus this term is 0 because there is no second span. So overall this term is 0. So we can write further simplified form MA into L 2MB into L equal to, if you simplify this equation, this is 3 times, this is also cancelled. So minus P into AB L plus A by L. So consider this is equation number 1. Similarly, you consider an imaginary span on the right side. Consider an imaginary span on the right side for the same system of loading because we have two number of unknowns. So for solving two number of unknowns, we need two number of equations. So the same loading is considered on the right side span. L1 is now 0 and I am going to name it is A dash. M A dash equal to 0. Here the normal M A will exist and also M B will exist. If you write the theorem of three moment equation, first you consider A dash, M A dash into L1 plus 2 MA into L1 plus L2 plus MB into L2 equal to minus 6A1 x1 by L1 minus 6A2 x2 by L2. So this is the general format. Now we can decide which term gets eliminated. So we are not considering the span L1 because it is an imaginary span. So this term will be eliminated. Okay. And moment at A dash is also 0 and there is no span L1. This term is also eliminated. And here L1 is 0. So this term is eliminated. Now 2MA into L2 is L. L2 is the span here which is L. L plus MB into L2 is now L equal to minus 6. A2 is the area of the BMT of this loading, the same as the above PAB by L with the span of L. So half into the span L and the height PAB by L and the centroid must be from here. The centroid must be from here because in this basic derivation for A1 we have to consider the centroid from left hand. For A2 we have to consider the centroid from B. In this case, the first term we consider the centroid from the left side, that is L plus A by 3. L plus A by 3. In the next term we have to consider on the right side, that is B side. So which is L plus B by 3. L plus B by 3 divided by L. Divided by the second term L2 equal to L. So now I'm going to simplify the terms. Similar term we can get like this. The only difference is PAB by L. Here L plus B. In this term it is L plus A. Here it is L plus B. And also here MAL, which is 2MAL plus MBL. So consider this is equation number 2. So I am going to write both the equation in the next page. So that is convenient. That is MAL plus 2MBL equal to minus PAB L plus A by L. The second term. Further we can reduce, take the span L common and bring it on the right side, which is MA plus 2MB equal to minus PAB by L square L plus C. So equation number 3 we can say in the simplified form. The same type 2MA plus MB equal to minus PAB by L square L plus B. So this is equation number 4. So we are going to solve these two unknown equations. By multiplying 3 into 2, we will get 2MA plus 4MB equal to minus 2PAB by L square L plus A. And fourth equation you directly consider as 2MA plus MB equal to minus PAB by L square L plus B. Okay, clear? Now we can eliminate any one of the variable comfortably. make the opposite signs. So 4 MB minus MB, which is 3 MB. And I am going to consider the common terms outside first, that is PAB by L square. Then the top term minus 2L plus A. Bottom term, it becomes positive. So plus L plus B. Okay. So I'm going to simplify this term on here. Minus 2L plus A plus L plus B. Okay. Minus 2L minus 2A plus L plus B. So you get minus L minus 2A plus B. I am going to replace B in terms of A. So that A plus B equal to L, B equal to L minus E. So minus L minus 2A plus L minus E. And finally you get minus 3. So 3MB equal to minus 3A into PAB by L square. So if we get cancelled 3, finally we get MB equal to PA square B by L square. MB equal to minus PA square by L square. So this is an important formula uh, in other units also. Slope deflection, moment distribution, whenever a point load acting in a span, we first consider the fixed end moment. As the very first step, we will calculate the fixed end moment. So this is the value on the right side support for a point load with a differential span of A and B. That is P A square B by L square is on the moment on the right support. Further, we are going to calculate on the moment at left support, that is MA plus 2MB equal to minus PAB by L square L plus A. This is equation number 3 already we have calculated. Now, we are going to substitute two MB values. What is the MB value? P A square B by L square. P A square B by L square minus PAB by L square into L plus A. So I am going to bring this term on the right side, where MA equal to minus PAB by L square L plus A. So this term plus 2PA square B by L square. So this term minus becomes plus. So I am going to take the common PAB by L square minus L plus A. So in this we get 2 as the remaining and 1 A is also remaining here. Okay. And multiply minus L minus A plus 2A. So it will reach to PAB by L square minus L plus A minus L plus A. From the basic span connections A plus B equal to L, bring this L on the left side and B on the right side. A minus L equal to minus B. Otherwise, we can write minus L plus A equal to minus B. You can replace minus B instead of this terms. Okay. Minus, sorry, PAB by L square into minus B. Finally, MA equal to minus PAB square by L square. So this is also a very important conclusion on the moment on the left side. So we have two values. One is PAB square by L square. Here P A square B by L square when a point load is acting on the differential span value. This formula will be employed all the units: stiffness method, flexibility method, slope deflection method, and moment distribution method. Kindly make it on the memory. Okay. So finally, we have concluded the analysis of fixed beam using theorem of three moments.